Hello, this is Tina Mathias, D&V Software's technical lead for its pipeline integrity management and risk assessment software, Synergi Pipeline. And today I'll show you Synergi Pipeline's Anomaly Finder tool. The Anomaly Finder tool is a desktop application that helps the integrity engineer to analyze and prioritize large volumes of data like what you would find from an inline inspection. It also helps the user to determine the corrosion and/or erosion growth rate profiles, and it allows the user to create activities and assign the prioritized anomalies to those activities in order to address them. So let's get started. The page you see in front of you is the metal loss rates page of the Anomaly Finder. It's the second tab on the main menu, and it's right after the initial setup page. Now the metal loss rates page, it's not mandatory that the user create these profiles. The profiles are intended to be used in order for the software to calculate remaining life and next inspection date. However, the user can actually input a uniform corrosion growth rate, and then that rate would be used in the remaining life and next inspection calculations. However, if you want to use a more detailed profile, you can, and there are different ways that you can do that. The first way is you can create your erosion or corrosion growth profile outside of the software, load it into the database, and then the Anomaly Finder can use it. You can also view that data and use that data in the Synergi Pipeline web application. The second way you can do it is you can create your profiles in the software. And for the corrosion growth rate profile, the way you would do that, and I'll show you that right now, is you would have to specify, is this an internal corrosion profile or an external corrosion profile? You give it a name. You have to specify how many segments that profile is going to consist of, and you can change that later on. And then you create the profile, and it says a new profile was successfully created. And then you have to specify when did the corrosion start. So I'm going to say that it started when the pipe was installed. I click this button, and then you see in the plot, you see the maximum corrosion growth rate profile, as well as here in orange the average. This is also shown in the plot below. So you have the 30 segments created, and then you have a max and an average corrosion growth rate for both of them. And the split and the merge buttons, they allow you to create more segments or to merge segments to have less segments. Now this is the rate column here, and this is the rate that's actually applied. And the way that that can be populated is you can actually populate it manually, or you can have the software just set the rate to the maximum calculated rate. I'll do that, and you'll see it's the maximum rate that's here. The other option is I could use one of the rates that are specified in the NACE ECDA standard. And even after I have it populated with the max rate, I can still go back and override those rates and change them to a rate that I think is more appropriate. And after I do that, I have the option to comment on why I changed the rate. Once I'm done, I can save my profile, and if I want the profile to be available in the web application, then I click Upload to the web. And now the profile can be used in the Anomaly Finder, and it's also saved to the database. One other way that you can create a profile for your erosion growth rate is if you have wall thinning or wall thickness measurements that you've been taking over time, you load that data into the software, and then the Anomaly Finder using linear regression will actually create an erosion growth profile, which then you can go in and look at and revise as you find appropriate, and of course comment on why you make those revisions, and then save it, and then that erosion growth rate can also be used in the Anomaly Finder. Now to the Identify Corrosion Anomalies page. So the default plot that shows up in the Identify Corrosion Anomalies page is the ERF along the odometer. Below the plot is a table with more explicit information on each of your indications that are displayed in the plot. And on the left-hand side is a different functionality that's going to help the user to prioritize these anomalies. Now, the ERF that you see here in this plot, this is the ERF that the Anomaly Finder has calculated given the code, the remaining strength code that the user selected. There are other plots that the user can use, and the reason for these different plots is we wanted to give the user the ability to visualize the indications in different ways in order to do this prioritization. So the user can have an ERF plot, can see the data safe working pressure, or POE leak, POE rupture, or POE over time. The user can select to see the information on a depth length plot, and I'll show you an example of that. And click on Run. And you can see the depth length plot, and I can see it for the code, the remaining strength code that I'm using, or I can see it for all of the remaining strength. So that's one way to visualize the data. I can also see it by orientation or clock position, by depth of the anomaly, by length, or the remaining life or time to failure. Let's go back to the ERF and click Run. There are also filter settings, so I can start to look at different segments of the data. For example, right now I'm seeing both internal and external corrosion. I can opt to only see internal corrosion. I click on Run, and now below the Run button it tells me that I am seeing in the plot and on the table 104 out of 1,912 total corrosion features. I can further go ahead and filter that down by saying, let me see the ones that have an ERF greater than 0.85, and I see there are 4 of those. Now let me show you an example of how I could prioritize those features. But first let me review the information in the table. The table has the identification of each of the features. It has the type, if it's an internal metal loss or external metal loss, its odometer position, its orientation, the depth and length of the indication, the ERF and safe working pressure that the Anomaly Finder calculated based on the remaining strength code. And then there's the prioritization column, and it's blank because I haven't prioritized anything. There's the remaining life that's been calculated, and then there's the original years to fail, with the starting point being the inspection date. There's the current years to fail, and the starting point for that one is today's date. And then there's the next inspection date that the software calculated, and then the reason for inspection, and that's how the indication failed in time. Will it fail by rupture or will it fail by leak? And rupture is defined as an ERF equal to 1, and leak is defined by the user in the setup page. So the user specifies what % wall loss makes a leak condition. And then there's the action deadline date, and this is tied to your prioritization. So immediates could have a 5-day time frame to address them. So the action deadline date for immediates would be 5 days after the inspection date. Again, this is set up in this is determined by the user in the setup page. The anomaly column is where you would select the anomalies that you want to prioritize. But I have filtered mine down to 4, and I know that all my internal corrosion anomalies with ERFs greater than 0.5, I want to prioritize them as immediate. So I select immediate here. I tell it to check all as anomaly, and then I select the identify as anomaly. And now you see in the prioritization column, they are all immediates. And in the action deadline column, it is put in a date, which is 5 days after the inspection date. Also in the plot, you'll notice that the points, they have changed from little red and yellow points now to blue X's, and this is because all identified anomalies are blue X's. I'll reset the plot. Go ahead and reset and run, and you can see the rest of the indications, and you can also see the ones that I've identified. When you click on an indication in the plot, a little pop-up comes up with some information on that indication, and it's also highlighted in the table below. There is some functionality for the plot where you can manipulate it in order to see data more clearly. For example, you can do like a zoom rectangle in order to zoom in. You can manipulate the axes. So I'm stepping it myself through the x-axis. You can save the plot to a PNG or JPEG in order to use it maybe in a report, and then I can go back and reset it to its original setting. Another way that the user can prioritize anomalies is using the automatic anomaly identification. And in this way, what the user would do is they could select to prioritize the anomalies either by what ASME B31.8S specifies an immediate or a schedule condition is, or either ASME or API 1160. So those are the two selections. And then you just go ahead and have the software identify the immediates based on those standards. And in that way, the user has a starting point. You can go in and review what the software has designated and decide to keep that prioritization, or you always have the option to override it and change it. One thing I'd like for you to notice is in the software, you'll find these little blue circles with the question marks. Those are our pop-up tooltips. So whenever you select one of those, additional information will be available to you. For this one, it tells you the exact criteria that ASME B31.8S and API 1160 uses in order to determine what is an immediate and what is a scheduled. Another feature on this page is our statistics panel, and it tells you the total features, and this is the total corrosion features, how many have not been identified or prioritized yet, and then it has the breakout of those that have been prioritized as immediate, scheduled, and monitored, and then the total that have been prioritized. So it's a nice running tally of your progress. Now below the filter is your corrosion rates panel, and I had mentioned earlier you have the option of just having a uniform corrosion growth rate applied. This is the default rate, and of course that can be overridden. And if you have profiles created, you can click on this button, specify use profiles, and then you can select the profiles that you want to use. I'll stay with my uniform growth rate. Below the corrosion rate is the calculate next inspection date with wall loss panel, and it calculates your next inspection date and your remaining life date. And this is based on the anomaly that's the most severe after your immediate and scheduled indications have been prioritized. So it's just looking at your monitored anomalies and also your unprioritized indications. And the one that's the worst, or the one that's going to fail the first, it sets the remaining life as well as the next inspection date. Now, your next inspection date, it can be the same as your remaining life, or the user has the option to set what the basis of the next inspection date is. Is it the same as the remaining life? Is it half the time to remaining life? Is it 60% of the time to remaining life? The user specifies that in the setup page. And below that is our POE functionality, which is new in version 6.2. And the POE, or probability of exceedance, is based on the tool accuracy as specified by the tool vendor or the tool manufacturer. The calculation for POE, it can be based on all of your corrosion features, or you have the option to specify the number of worst corrosion features that you want to base your POE calculation on. And I'm going to go using all of them, or all 1,912. And then you have to specify a confidence limit. And this is the default limits. I'm going to go ahead and change this to 97. You have to specify a confidence limit on the anomalies level, so per anomalies, for its calculated POE leak and POE rupture, and then also for the entire section, its POE leak and its rupture. And then you have the option to have POE calculated for several intervals in the future. I'm going to have it be calculated for the next 3 years, so I say 3 as a number of calculations, and the interval of 1 year, so that the POE will be calculated in year 0, 1, and 2, so 3 intervals. I can go ahead and go on and have, for each of those calculations, have it take out the 5 worst or the 10 worst, or both, for each year, for each one of those intervals. I'm not going to go with that option initially. I'm going to go ahead and have it calculate the POE. And here, this calculates the POE for the section. It's calculated it for year 0, 1, and 2. There's the POE leak and the POE rupture that's been calculated for each of those years. And then also you see that the limit was reached at year 0 for both POE leak and POE rupture. Also notice that the plot has changed. It's now the POE over time plot. And the red is the calculated POE rupture, and the blue is the calculated POE leak. And these are the 2 thresholds, the rupture threshold and the leak threshold. Now what I can do is I can go back and say, let's try to calculate the POE again, but let's take out the 10 worst in each year. So calculate POE again, and we see now that a new column has been added to the table. So it has calculated the POE leak when the 10 worst were removed each year, as well as the POE rupture, 10 worst removed each year. In the POE leak case, the POE limit is not reached. However, in the POE rupture, it is still reached at year 0. We also have a what-if scenario calculation. There's 2 of them. Instead of being tied to the 5 or 10 worst, the user can actually opt to say the number that they want to be ignored or removed from the POE calculation each year. Another option the user has is the mitigate at year what if. And in this option, the software actually selects the number of indications and specifies which indications need to be addressed each year in order for the section POE limit not to be reached. The POE calculation, its function is to help the user to determine when they should be addressing their scheduled anomalies, because possibly it's not financially feasible to address the immediates and the scheduleds all within the same time frame. And with the schedules, you do have a little more time, so you would like to see, maybe I want to address my more severe schedules first, and the POE is intended to help you with that. There's also functionality in the filtering and the plots, like the years to fail and showing growth in plot, and then the remaining life and time to failure plots that also are intended to help the user in scheduling when to address the scheduled anomalies. The Identify Non-Corrosion Anomalies page is very similar to the Identify Corrosion Anomalies page. It does have filtering capabilities and also has the automatic anomaly identification. After your non-corrosion and corrosion anomalies have been prioritized, you can go to the Follow-up Activities page. And in this page, you can actually create activities, or you can use existing activities or activities that have been created in the web application. You can select these activities, and then once you select them, you get this plot of the prioritized anomalies as well as this table of prioritized anomalies, and you can start selecting them as to the ones that you want to have addressed by your selected activity. Another thing you can do is you can, once you've selected those anomalies, is you can mark anomalies that are near to those. So if you knew that you were doing a certain length dig and you wanted to see all the other anomalies that would be captured by that dig, you could have the software actually specify those for you. You can have it specify the ones that haven't been assigned already to an activity, or you could have it specify all of the nearby anomalies. So once you assign it here, you click Update Assignment for this activity, and this warning message is saying that the date is later than the action date, and that's fine. And now these two have been assigned to the Validation Digs activity. And this also shows up in the Synergi Pipeline web application. This concludes the demo of the Synergi Pipeline Anomaly Finder. Thank you for your time.